In this video, we are going to apply the formula of the sum to infinity to solve a problem involving probabilities. Betty and Jim take turns to throw a fair dice. The first player to get a 1 wins the game. Betty throws the dice first. We need to find the probability that Betty wins the game. Let's understand the game first. Betty and Jim take turns rolling a fair dice, with each number from 1 to 6 equally likely. Since the dice is fair, the probability of getting a 1 is 1 over 6. And the probability of not getting a 1 is 5 over 6. The game will go on until someone gets a 1 to win the game. Since Betty throws the dice first, Betty will win on her first turn if she rolls a 1 immediately. So she has the probability of 1 over 6 to win on her first throw. Of course, Betty may not get a 1 on her first throw, which has a probability of 5 over 6. However, if Jim also fails to get a 1 on his first throw, Betty will have another chance to get a 1 and win on her second throw. Moreover, even if Betty doesn't win on her second throw, as long as Jim doesn't get a 1 on his second throw, she still has a chance to get a 1 and win on her third throw, and so on. So, as long as Jim keeps not getting a 1, Betty always has a chance to win, no matter how long the game lasts. Let's write down the probability that Betty wins the game. It's equal to the sum of the probability that Betty gets a 1 on her first throw, the probability that Betty gets a 1 on her second throw, the probability that Betty gets a 1 on her third throw, and so on. The probability that Betty gets a 1 on her first throw is 1 over 6. The case that Betty gets a 1 on her second throw only happens when both Betty and Jim don't get a 1 on their first throws, and Betty gets a 1 on her second throw. The probability of this case is the product of 5 over 6, 5 over 6, and 1 over 6. Similarly, the case that Betty gets a 1 on her third throw only happens when both Betty and Jim don't get a 1 on their first 2 throws, and Betty gets a 1 on her third throw. The probability is the product of 5 over 6, 5 over 6, 5 over 6, 5 over 6, and 1 over 6. Watch closely. These probabilities actually form a geometric sequence, where the first term is 1 over 6, and the common ratio is the square of 5 over 6. And the sum of these probability is equivalent to the sum to infinity of this geometric sequence. Using the sum to infinity formula, we can find that the probability that Betty wins the game is 6 over 11. We can see that Betty, the one who throws the dice first, has a slightly better chance of winning. Therefore, in this kind of game, it does matter who throws the dice first. That's it.